For this lab, you're going to be using a high voltage generator, a function generator. Here's the oscilloscope, and then here's the laser setup. Now, this is a nitrogen laser, which is actually relatively powerful. We have a slight problem with this lab in that to save data, we have to use this one USB flash memory. It's the only one that seems to be able to connect to the oscilloscope, so don't lose that. Of course, make certain everything is plugged in and that the power strip is on. And then, of course, we want to turn on the oscilloscope. Unfortunately, this is very slow because it's running Windows 95, and that's actually the source of our problem with the USB memory card, because the operating system is so old. Also, this disk drive makes a lot of very loud, annoying sounds. Every now and then it'll stop, but for the most part we just have to live with it. After about 5 minutes, the oscilloscope has started up, and we're starting to see a signal. Now, we want to turn on the monitor on top, which is actually just the same thing as the screen on bottom on the oscilloscope. It's just easier to see this way. This is actually a really very high-end oscilloscope. This is one of the best oscilloscopes that money can buy. So we want to first make certain that the parameters are set up. Left and right represents time, and up and down is voltage. You can set those on the oscilloscope, and we'll show you exactly how to do that in a moment. The function generator has to be connected to the oscilloscope. It's connected on the left-hand side to channel 1, and on the function generator's right-hand side it's connected to the oscilloscope in channel 4. Now the first thing we want to do, make sure that channel 1 is on. We do that by pressing that button there, which lights up. Make certain that we're reading DC type of voltage, and that we have what's called a 50 ohm coupling. That's due to the nature of the cable. Okay, now the next thing we have to do is make certain that the oscilloscope is properly triggered, which is done by this control panel on top. And one thing that you definitely need to pay attention to is that you're triggering off the proper channel. And here we want to trigger off channel 1, which you control by this little button here. And of course make certain all the other settings are correct. The next thing you need to do is make certain that all the acquisition parameters are correct, which you do with the mouse and the pull down menu. And now what we're doing is we're setting up the function generator. Just consult the manuals for the proper settings for that instrument. Now, while various acquisition parameters are controlled by the pull-down menu, the time and voltage axis are actually controlled by the oscilloscope. So, as you can see here, the top knob changes the time per division, and we're just adjusting that according to the manual. And we want to change the voltage per division, which is the y-axis here, and you can see that we're making the proper adjustments there. Now with everything properly set up, we see a waveform here, but it's a little too high, so we have to increase the number of millivolts per division until we can see the waveform properly. There's going to be a lot of adjustments done as part of this module. Now what we're going to do is change the function and even look at other functions on channel 4 as shown here. You see, it's very common with an oscilloscope to trigger off one channel only to view the data off another. Now that happens when you actually do the fluorescence. You're going to trigger the oscilloscope to take data off the laser signal, but you're actually only going to observe the signal from the PMT, which observes the fluorescence. Now what we do here is, as you're still working with the function generator, you're going to learn how to make measurements with the oscilloscope. Now the oscilloscope actually has many different ways. You can just look at, count the number of divisions between, say, 2/12 of the signal, and you know the amount of time per division. That gives you frequency. You have these options off the pull down menu on the left to automatically make measurements. But a really good way is to use markers. So we're going to show you how to use markers next. Now to set them up, you just want to follow the manual. You have to set certain channels, and then you're going to manipulate that with the mouse. As shown here, you can move the markers left and right, and you see that little square actually follows the waveform itself. We can set that to the bottom of the signal. and then we can set the other one to a certain location right next to it. And in this way we can measure things like the time between the two markers, and that's shown right here on the bottom right. And from the time between the two markers, then you can calculate things like frequency and tell us, does it match what the signal generator was set for? Hopefully it does. Okay, so the next thing we want to do, we have a couple more things to do with the oscilloscope, but we want to learn how to save data. You definitely need to save your data. So you're going to do that with the pull-down menu here, and you want to save a waveform, and there's several more parameters. You have to get these right. Now remember that we're triggering off channel 1, but our signal is on channel 4, so make certain you save channel 4. Now you're going to have to be able to plot this somehow, so you want an ASCII file, and that can be read by anything, which is not called .txt but .csv here. God knows why. Now remember, we have to save things on that funky USB that only works with Windows 95, and that's right here in E. So just pay attention and make sure you get that right. Okay, next thing we do in the first day is work with functions. We can take a signal and modify them. In this case, we're going to take the derivative. And that's here, instead of derivative, it's differentiate. You tell it what channel, and there we go. You can change the waveform with the function generator, and you can see, like in the case of the purple sine function, the derivative is a cosine function. And when we can look at the derivatives of square waves and all kinds of different shapes and forms. Okay, so now we've pretty much completed all the assignments on day 1, so obviously it's time to shut down by turning off the function generator. And we also want to reset the oscilloscope back to its default settings, as you do here, and you're going to spend the rest of the day preparing solutions for the actual fluorescence experiment itself. Okay, so now it's day 2, and we're going to do the actual fluorescence experiment. Now the first thing to do is to make certain that the photodiode is connected to channel 2. That's ultimately going to be our trigger. That's right here. So we got to make certain that we turn off channel 1, which we won't use today, and turn on channel 2. Again, double checking we've got the right cable, and we set the various parameters correct, like the coupling to 50 ohms. And of course there's many other adjustments we must make, and you're going to continuously make adjustments to the voltage per division, which is here. And we want to put that on the recommended setting. You may have to adjust that once again, but it shouldn't take you too long to find the trigger signal. And we're adjusting the x-axis, the time axis, as shown here. And of course, don't forget your trigger settings. Now, we're not triggering off channel 1. We have to make certain we trigger off channel 2 and make sure the other parameters are correct, and they're all in the lab manual. Okay, it's laser time. Most important, have these laser goggles on. And here is the nitrogen laser itself. The beam moves forward to the table, and it's actually a pretty powerful laser. That's why you have to be very careful. And the first thing it hits is this beam splitter here, so some of the light moves to the left and some moves forward. The light that moves forward is going to be attenuated by basically this dark glass filter, and behind it is the actual photodiode, the laser signal, or more accurately, the trigger signal. Now here's the sample container. It's fairly simple. We're just going to put, the light goes through that focusing lens, and then it hits the cuvette, which is stored here with your sample. The light from the sample, the fluorescence, will go through this monochromator shown here, which should be at the right wavelength. The signal from which is amplified by this photomultiplier tube shown here. Now, if you have the laser on, before you turn the laser on, you must cover it by this box. This is a legal issue. We have no options on this. Alright, here we're turning the laser on with the key, but there's no laser emission yet till you turn this knob, which is just the repetition rate of the laser pulses. The pulses are very short in duration, just a few nanoseconds, and we're going to turn it up to the highest repetition rate. Okay, now we got to make certain that the trigger settings are correct, and the trigger level is also correct, which is shown by this brown line. You can raise it up and down until you can see the actual signal from the laser. The next thing we do is to characterize the laser emission itself, and we have to change some of the acquisition parameters such as averaging as shown here. And we're also going to change the time axis, and we might also change the y-axis till we have a really good look at the laser pulse according to the oscilloscope. And what we can do is use the markers, for example, to measure exactly how long is the laser pulse itself. Now that we've characterized the laser, we're now ready to do the actual fluorescence experiment, where the first step is to turn on the high voltage power supply. Now you must be very careful with this. All the knobs should be at 0. Polarization is negative. And remember, this thing, if you do this the wrong way, you could destroy it or hurt yourself, or probably both. So be very careful and follow these instructions exactly. Now the first thing we're going to do before we turn up the power is we have to set the oscilloscope up to read a signal when the signal is present, when we have the power high up enough. Now that's going to come from channel 3. Make certain that the coupling is 50 ohm, and we're already triggering, so we should be okay. We do want to make the settings in terms of voltage per division low enough that we can definitely see it, so you're seeing that here. Now of course we have to add the sample to the sample holder here, and the laser's off or you're burning your hand up. And if the high voltage power supply was turned on with the cover open like this, congratulations, you just destroyed a $10,000 photomultiplier tube. So of course the high voltage power supply is also off. We're about to turn on the laser, so before you do that, it's covered, and now the laser's on. And the next thing to do is to turn on the high voltage power supply. So the first switch on the left, the power supply is turned on, and then before you turn on the actual high voltage, you have to wait for that little indicator light, the little white one, to turn on. And there it goes. It's a little dull, but you can see it. And now we can turn on the actual high voltage. This is done for safety reasons. Now we're going to slowly turn up that second knob to the right from 0 to 100 to 200 volts. And what we're looking for is a signal, which we see right here. And as we turn up the voltage further, the signal gets bigger. Now I know the signal right now is upside down, but we're going to fix that with the oscilloscope later. Right now we actually want to be at about 600 volts, so the first thing to do is to turn that knob down back to 0, that first knob to the left to 500, and then we'll turn that second knob to the left to 100, and there you go, that's 600. They add together. And as such we can see the signal growing and growing. Now we want to position it so that we can see it a little bit better. So we're going to raise it and move it a little bit to the left. And you're going to do that with the oscilloscope controls. See, now that looks much nicer. Now what we have to do is take care of the fact that our signal is upside down. And we're going to do that with the functions. Now you've already worked with functions in the first day, so you should know how to do this. You're going to change channel 3. Remember, our signal is coming from channel 3, and the function is invert. And there it is. You can see the rise due to the excitation of molecules, and they're fluorescing, so that gives us a rise in fluorescence, and they naturally decay as chromophores naturally decay, the time scale of which you're going to measure. And to do that, you can at first get a good idea with the markers that we used earlier. Okay, so you're going to do that for all your solutions, and it's shutdown time. Make certain all the knobs are turned to 0. That's really important. And we turn off the high voltage. You already know how to take care of the oscilloscope from day 1, but of course you better turn off that laser and turn the key, and take care of your chemicals as well. And good luck with the data analysis. That is all she wrote.